Okay. Good morning, everyone. First, let me introduce myself. I'm Jane Goodyear. I'm the Director for Undergraduate Teaching and Learning in the School of Engineering and Advanced Technology at Massey University in New Zealand. Now, I agree with you, Chairperson, that this session is one of the most important sessions of this conference. And in fact, can anybody see the arrows in my back? I've spent 2 years of my life actually doing a major curriculum redesign for the Bachelor of Engineering degree at Massey University. And in fact, I've got two ways of looking at it. One, I feel very privileged to actually have the opportunity to actually do a major redesign of an engineering programme. But secondly, you see the arrows, it's quite a task to do actually in terms of doing a significant change with academic staff and a programme which has been going for quite some time. So further ado, sorry about that. What I'm going to be talking about is giving you our story about how we've gone through curriculum redesign at Massey University. Just a quickie about why we changed, why we felt compelled to change. Also, I'm going to explain some of the key aspects of our curriculum. And then, more importantly, I'm going to tell you how we've used the CDIO curriculum to actually benchmark what we've done in our change process. One thing I also want to point out to you at the moment is that that's a pretty picture. Okay, this is you'll see some more pretty pictures through the presentation, and this is part of our marketing campaign. Because even though we are focusing very much on the curriculum and trying to develop world-class engineers, we're also conscious of actually embedding the change in the culture around in the school itself, how we put ourselves to the rest of the society out there, and we want to tell a story. And I'll be telling you more about the biomimicry and the observe, invent, realise slogan or strapline we use to actually put over what we're about in Massey Engineering. For those of you who don't know much about New Zealand, it's on two islands. We're based in the North Island. I'm actually part of two campuses. The main campus is in the Palmerston North, which is about 2 hours north of Wellington. And we also have a campus at Albany in Auckland. And essentially we have 600 students based over these campuses, so not a huge cohort at all, which actually makes it quite good for any change as well, so that's good. But we've been going approximately 50 years. Now, why have we changed? There's a lot of things going on, as you know. I mean, we've got our external influencers. For us at Massey University, we've had static student numbers over the last 10 years. Also, we've got the International Engineers Alliance, and IPENS is our local signatory to the Washington Accord, the Institute of Professional Engineers New Zealand. And also we've got our industry guys saying, and in fact some of the comments from the previous speech is quite right. And what are they saying? Graduates, we want rounded graduates, not just technical boffins. Graduates should aspire to leadership roles. We should have emphasis on more professional skills. You know, the things we know and care about in this conference. But also we've got internal issues such as attrition and also engagement, particularly at first year from the transition from school to university. Also, Massey University is a top 200 university in terms of the research rankings, and so our staff are very, very much research focused. And also, we haven't had a major redesign of our Bachelor of Engineering programme for probably 10 to 15 years. So in terms of minor reviews, we've got an overly tweaked curriculum, and in fact, probably siloed in terms of how it's developed. And it's no fault of anybody, it's just the way it happens. And again, we 2 years ago had a reaccreditation. We did get reaccredited. We also did an internal review, and these are some of the comments. Students are death by PowerPoint, so what am I doing to you guys? And also, again, it's quite clear from the students' perspective, there's a lack of practical engineering-related experience going on. So that's really a bit of background of why we thought 2 years ago as an executive to actually undergo a significant change of our curriculum. Before I go on, actually, I'll just go back. You'll see my scribbles on the board here. I'm part of the School of Engineering Executive, and in fact we had a discussion with the Aston guys at lunch yesterday about should it be this change of evolution or an evolution. In fact, I think it's a bit of both. We've taken on the fact that it should be a revolution, led from the senior leadership, but in fact the work is being done at grassroots level. So I'm part of the exec. Sorry. Right. I'm part of the exec, and I'm also leading this, what we call the BE working group, and there's 10 academics from various disciplines. We have chemical and bioprocess engineering, electronics and computer engineering, mechatronics, product design engineering. So we've got quite a broad array of disciplines. So we've got the inner group, and we've been working on this curriculum for 15 months now. Since February this year, we've actually widened the working group into what we call learning teams, and we're focusing very much on the first 2 years of the curriculum. And these learning teams, there's approximately 40 academics, and in fact, they're not just engineers, we're also part of the College of Sciences at Massey University, and you'll see here we're having working with physicists, mathematicians, computer scientists, biologists, chemists, and so forth. So we have really, or I've had a real hard time trying to bring the disciplines together, but I think I've succeeded. Also, what's interesting, and in fact I was really pleased last week, a lot of people from around the university said, hey, the Vice-Chancellor keeps talking about what you guys are doing in engineering. So even though he knows about it, he's known about it for some time, it's now at a very senior level in the university about what sort of things we're doing in the engineering, and that's just great, because you need that top support as well as what's going on in the grassroots level. So the first thing we did is an easy one, rationalise the measures. You see that in 2009 we had loads. It just confused the incoming students. Industry really didn't know the differences. There wasn't much difference anyway. So we've actually, from 2012 next year, and we're actually launching the new degree next year in February, we're going down to 5 majors. Now, what I'm going to talk about is actually what we're doing in terms of benchmarking against the CDIO standards. We've actually taken the 12 standards and sort of like said, where are we? And you can see here, we've got, we're quite all right with the programme goals, the curriculum design, the workspace, because here I've sort of like gauged it. 0 is we're easy, we're conforming. Whereas out here in number 5, we're having quite significant difficulty achieving the standard. And you'll see around here, mainly that's to do with the faculty and staff, and I'll go into that more in a while. Now, one of the things I was challenged to do with my working group was to actually tell a story about what's the graduate. And in fact, you know, we've got a graduate profile, there's lots of words and things like that, but we wanted something where we can tell a story quite visually about the graduate attributes. And we've represented this as a house. And in fact, I've taken this from the Toyota production system. I'm a manufacturing engineer by trade, so I've done a bit of plagiarism there. But essentially, the story is that we have to have a firm foundation. And the firm foundation is the technical knowledge. That goes without saying. And in fact, a lot of the companies, they take that for granted. But also, we have the walls of the house. And we've split this into Design and Achieve, which is the equivalent to the CDIO part of the syllabus, and Professional Practice. In fact, we've called it Engineering Practice, which is more the interpersonal and personal attributes in the CDIO curriculum. And in fact, what we've done here, this is our strapline, Observe, Invent, Realise, and this is the home. This is what we're trying to instill in terms of our students and our staff. It's about getting them to think outside the box, observe, think creatively. And in fact, you'll see it, as I said, the biomimicry. We're trying to tell that story to our students and staff. Also, what we've tried to do is relate the graduate profile to the curriculum itself. And what you'll see here is that sides of the house, the professional practice and the CDIO, is actually a quarter of the curriculum. So every year we're actually building on our project-based learning in terms of getting them actually doing something, doing real engineering. And in fact, the 75% is the technical focus. In fact, our 25% project-based spine, and this is in my paper as well, we're trying to develop these skills of the CDIO and the interpersonal personal skills from year one. And in fact, we want to focus on being creative and not constrained in anything in year one, to actually in year 4, when they're dealing with an interdisciplinary, real-life engineering out in industry problem. Active learning, this has been a bit of a challenge. This is our current first year, about doing physics, taught by physicists. There's no engineering perspective. They focus on breadth of topics, and in fact the teaching is quite passive. But what we're actually doing now, I'm trying to do an interdisciplinary teaching team in terms of, dealing with the physics and engineers. The physicists develop the concepts. The engineers come in and pull from those concepts, working on real engineering problems. And that has been a significant shift of the way we do things. The enhancement of faculty. As I said, we want people to see the world differently. So, you know, we're really trying hard to change the culture. And in fact, this marketing campaign, you'll see it around New Zealand on TV and all sorts of stuff. But we're also trying to change the way we recruit, and in fact, getting more industry experienced faculty. And in terms of teaching, we're, as I said, mentioned, doing interdisciplinary learning teams. We're holding a lot of workshops, teaching and learning, sharing lunch. We've got an online community. At the moment, this group is all online, and we develop our courses and share things and blogs and things like that, so that we're trying to get that community. And also we're looking at using threshold concept theory. So if anybody wants to talk more about that, I'll be willing to go through what we're doing there. Anyway, conclusions. You can still see the arrows. It's not for the faint-hearted, a full curriculum redesign. And in fact, it's been very difficult for me in 15 minutes to actually tell you about 2 years of what we've been doing. And the baseline is that faculty make and break, and most of my time has been actually with the process and working with faculty to actually get the ideas of active learning, CDIO and so forth through. But also what I liked about using the CDIO standard is that it allows you to prioritise where to focus and gives you an idea for, you know, what to work on. And in fact, because it's part of an international community, it's given us confidence that we're going in the right direction. So there you go. Thank you very much.